Assalamu alaikum. I hope everyone is fit and fine. In this video, we will solve radical equation of type 2. In my previous video, we solved radical equation of type 1. Let's solve question number 5 of exercise 1.4. We are supposed to remove these radical signs. How we are going to remove it? We'll square both of its sides and we'll write squaring both sides. By squaring both sides, we are able to remove the radical sign. And here we have square root of x plus 60 whole square. On the left hand side, if you see, we are having first algebraic identity, which is a square. So the square of first term, then 2ab, and then we are having square of the second term, which is b square. So x plus 21 square root of x plus 21 whole square. And on the right hand side, square will get cancelled by 2, so we are left with x plus 60. Now let's solve the left hand side. Square will get cancelled by root x plus 5, and last term square will get cancelled by root. We are having x plus 21. And here we have already read about the property of radical. Here we have, if we are having separate radical signs, we can combine them. So we can easily multiply the two terms, and the right hand side will be as it is written. Now x plus x becomes 2x, and 21 plus 5 becomes 26. And here we will multiply the two terms. Here we'll get x square plus 21x plus 5x, and here we have 505, and here we'll get this. Now we'll take the term without the radical sign to the other side, and we'll be left behind with just this term. We'll solve it. 21x plus 5x becomes 26x plus 105, and here we have 60 minus 26 plus x minus 2x, right? So we'll just solve the right hand side. We'll just simplify it. So here we'll get 34 minus x. So our type 2 is converted into type 1. We are left with one radical sign. We'll take the square again. We'll write squaring both sides, and we'll take square on both sides like this. 105 whole square, and here on the right hand side this. So square is on 2, it will become 4. Square is on radical sign, it will get cancelled. So we are just left behind with this term. And on the right hand side, we are having the second algebraic identity, which is a square. So it becomes 34 square minus 2ab and plus b square, means x square. So we'll open up the brackets, we'll open up all the squares. So we are having 4x square, and here we have 104x, and here we are going to have 420. And when you will take square of 34, it becomes 1156, and here we have 68x and plus x square. Now we'll move all the terms to the right hand side. To the left hand side, 4x square minus x square plus 104x plus 68x plus 420 minus 1156 equals 0. Now we'll just further simplify it. 4x square minus x square becomes 3x plus 104 plus 68 becomes 172x, and here we are having minus 736 equals 0. Now we are going to break the middle term. We'll use these two factors. 3x square will as it is. We are having we'll write minus 12x and plus 184x. When you'll solve it, you'll get 172. So let's take common factors. Here we have 3, 4, and 184 is common. So we are left with x minus 4, and then again x minus 4 is the common factor. So we are left with this. Now we'll write either the first check both factors equal to 0, so x minus 4 equals 0, or 3x plus 184 equals 0, and then x equals 4, and then x equals minus 184 by 3. We'll not write down the solution set. Before that, we are supposed to check the values. So let's do the checking process. We'll insert each value of x in the given equation. Let's write the given equation: square root of x plus 5 and square root of x plus 21 equals square root of x plus 60. So instead of x, we'll write 4 plus 5, and then square root of 4 plus 21 equals square root of 4 plus 60. We are having 9, we are having 25, we are having 64. Open up the square roots, we'll get 3 plus 5 equals 8. So this means x equal to 4 satisfies the given equation, so it will go into the solution set. Let's check for the other value of x. I'll insert the values directly because the equation is already written. So instead of x, I'll insert minus 184 by 3 plus 5, then square root again minus 184 by 3 plus 21 equals minus 184 by 3 plus 60. These are two fractions. We'll make them one fraction so that we can see whether the left hand side is equal to the right hand side or not. So in all the three fractions, we are having 3 as an LCM. Okay, so let's write down the numerator: plus 15. Here also minus 184, 63. Here also 3 is the LCM, minus 184 plus 180. So let's solve it further. We'll have minus 169 by 3. We'll have minus 121 by 3. We'll have minus 4 by 3. Now let's open the square root. When you'll open the square root of 169, it will become 13. Square root is also on minus sign. It will become iota over square root 3. Again, when we'll open the square root of 121, it becomes 11 iota divided by square root 3. Here we have 2 iota divided by 3. If you see, the left hand side is not equal to the right hand side, so this thing for x equal to minus 184 by 3, it will not go into the solution set. So at the end, we'll write down the solution set, and the only value that satisfied the given equation was 4, so it will go into the solution set. And for the other value, we'll write just the extraneous root or the extraneous solution. You can say extraneous root is minus 184 by 3. So this is how we are going to solve radical equations of type 2. In this case, we have taken the square both for 2 times, right? So I hope the steps of working are clear to you. Thank you so very much.